Good morning, children. Welcome back to Curiosity IIT Physics Foundation classes. So today we are in projectile motion, unit 5, assignment. So one of the most important application of kinematics, that is projectile motion. Okay. So in the kinematics, first we have learned in the grade 8 and in the grade 9 starting chapters, we have seen only one-dimensional motion. Okay, motion along x-axis and motion along y-axis. Independently, we have learned about the motion along x-axis. And independently, we learn about the motion along y-axis. What happened if we combine this x-axis motion and y-axis motion? That comes under projectile motion. That is, we call it as a two-dimensional motion. The best example of two-dimensional motion when aeroplane is taking off. Okay, so it is a two-dimensional motion. So what do you mean by projectile motion? Or what do you mean by two-dimensional motion? Projectile motion is defined as is a combination of x-axis and y-axis. Let me write the definition. Projectile motion is nothing but motion along x-axis plus motion along y-axis. The x-axis motion and y-axis motion, if you combine, you will get projectile motion. If this is x-axis, this is y-axis. Motion along with respect to these two. So this is what? Projectile motion. So in the projectile motion, the path followed by the particle or object must be a parabola path. It must be a parabola. Okay. And whatever the linear equations of motion we have applied, the same linear equations of motion we can apply for projectile motion also. So how you are saying we can apply the linear equations of motion for this projectile motion? And we know that those linear equations can be applicable if the acceleration is uniform. But how could you say the projectile motion where acceleration is uniform? Yes, why acceleration is uniform in projectile motion? Because if you take x-axis motion, in the x-axis motion, in x-axis, our velocity is constant. Velocity is constant. Velocity constant bole to velocity constant par mein it is saying that if velocity is constant, whatever the acceleration zero is zero. So along x-axis, the acceleration is zero. So what about y-axis motion? Along y-axis, velocity is not constant, but acceleration is constant. What is that? No, your acceleration will be taken as acceleration due to gravity. Acceleration due to gravity. We consider it as a acceleration due to gravity. Simple. For example, a body projected with an initial velocity u such that it is making an angle theta with a horizontal. Now this initial velocity u has two components. Now every vector has two components, x-axis and y-axis. So here ux I cap plus uy j cap. What is ux? Ux is equal to u cos theta. Velocity has two components, horizontal component and vertical component. The horizontal component of initial velocity is taken as u cos theta. The vertical component of initial velocity is taken as u sin theta. So our ux is equal to u cos theta. Our uy is equal to u sin theta. U sin theta. Okay. So now, if a body projected with the initial velocity u, magnitude of the velocity is u. But if you write in a vector notation, it is ux I cap plus uy j cap, and ux is equal to u cos theta, uy is equal to u sin theta. So what about the final velocity along x-axis? Our final velocity along x-axis vx is equal to ux, that is always u cos theta, because acceleration is zero. Acceleration is 0. Because why x-axis ka velocity? Many people may have one doubt. Why x-axis ka velocity constant? Remember, if your velocity along x-axis is constant, then only the body follows the parabola path. Then only body raised to certain height and again falls onto the ground. It reaches the same plane of projection if our initial velocity is constant along x-axis. So here observe the direction of initial velocity along x-axis here, this velocity, wherever you take, for example, here I'm taking, I want to find out the velocity. So tangentially, if you take here the velocity here, this is a tangential direction. This is velocity, final velocity. Now this final velocity again classified into two types now, vectors, Vx, Vy. Observe now here, parallel to x-axis. If you take here also, Vx is parallel to x-axis. Here also Vx. Here Vx is same. Here Vx is same. Do you have observed any change in direction of velocity? No, no. If there is no change in direction of velocity, I can say velocity is constant because magnitude anyway I'm keeping constant. Yes or no? Here I'm not changing the magnitude of velocity. Here I'm not changing the direction of velocity. Hence I can say velocity along x-axis is constant. Velocity along x-axis is constant. If velocity along x-axis is constant, velocity acceleration along x-axis is 0. So what about our acceleration along y-axis? That is g. Okay, that's why we can apply the linear equations of motion for projectile motion also. Now let us see individually whatever the four equations we have for x-axis motion and y-axis motion. Together, if you write combinedly, then it comes under the projectile motion. Okay, so just now I written total initial velocity is uxi cap plus uyj cap. Initial velocity along x-axis is u cos theta. Initial velocity along y-axis is u sin theta. Whereas final velocity along x-axis is u cos theta. Acceleration along x-axis 0, 0. Now, what about displacement distance traveled by the body along x-axis? We know s is equal to ut plus of at square. Ut plus of at square. I need displacement along x-axis, which is ux into t plus of into ax into t square. Here is x, displacement along x. I am taking as x. Ux is u cos theta into t plus of into, here my acceleration is 0 into t square. So where the displacement along x-axis for a projectile motion is u cos theta times of t. U cos theta into t will get, this entire value becomes 0. Okay. Displacement along x-axis is u cos theta into t. Final velocity along x-axis is u cos theta. Initial velocity along x-axis is u sin theta. Acceleration along x-axis is 0. Four factors. Done. That's all. Now let me explain you vertical motion here along y-axis. Along y-axis, what is my initial velocity? Uy is u sin theta. Uy is u sin theta. Then acceleration along y-axis is ay is equal to minus g. Why minus g, sir? Because body is going upward initially, but acceleration due to gravity acts vertically downwards. Now, what is the final velocity? Final velocity का formula क्या है? V equal to u plus at. V equal to u plus at. Which final velocity I am finding? Final velocity along y-axis. So Vy is equal to uy plus ay into t. Uy का value is how much? That is u sin theta minus gt. So the final velocity along y-axis u sin theta minus gt. U sin theta minus gt. So what is the displacement, sir? The displacement along y-axis, that is height traveled by the body. The height traveled by the body along the y-axis. That is, anyway, we have to use the same formula, ut plus of at square. So substitute the values, sy, uy, ay. Sy I am taking as y. because along the axis now. Uy is u sine theta into t plus half into minus g t square. So write completely here. U sine theta times of t minus gt square by 2 is the displacement along the axis. Okay. So we have seen initial velocity along the axis u sine theta, final velocity along the axis, acceleration, displacement. That's all. Now, so for this, we have to find same as like we have done in the linear motion, that is motion under gravity. What is the maximum height reached by the body? What is the maximum horizontal distance traveled by the body? That everything here also we are solving. That everything we have given the formula in your running notes in your regular classes, and you can have a look into that. Okay. Means here maximum height ka formula is there, range ka formula is there, time of flight formula is there, time of ascent formula is there, everything. Time of ascent if I take, time of flight if you are taking, that is 2u by g na, but here 2u sin theta upon g you will get. 2u sin theta upon g, this is the time of flight. H is equal to u square, maximum height h is equal to u square by 2g. Here h is equal to u sin theta whole square, u square sin square theta by 2g you will get. That's all. Okay, now u square sin square theta upon 2g. So what about range? The horizontal range traveled by the body is u sin 2 theta upon g you will get. U sin 2 theta divided by g you will get. This is a range, or 2u sin theta cos theta divided by g. So these are the range formula and different. Okay. Is it clear? Any doubts? So this is about the range. Yeah. Next, we'll look into the assignment questions one by one. Body projected vertically up, and after some time it reaches the point of projection. After some time it reaching the point of projection. In this case, distance and displacement both are equal. No, never. Distance travel is zero. No. Distance travel is equal displacement covered. Distance travel is not zero, but displacement becomes zero. Simple na. Here you are. This is your position. Now you are throwing a body vertically upward. Height traveled after reaching the maximum height, again it is falling down. It reaches the point of projection. Where it is started, there only it reached. So our displacement is gonna be zero. But height is there h1 and h. So h plus h2 h. That is distance is not equal to 0, but displacement must be 0. Because initial and final positions are same. Body projected vertically up from the ground. It is projected vertically up from the ground. If air resistance is considerable, if I consider the air resistance, then which of the following cases is correct here? So that is what he is asking. Have a look here, children. Yeah. Projected vertically up from the ground, if air resistance is considerable. So this is the ground. From here onwards, a body projected vertically upward. It is projected vertically upward. If it is projected vertically upward and air resistance is considerable, he said. So anyway, you are applying certain initial velocity to throw the body upward. Means indirectly you are giving some force. That force is enough to overcome the air resistance. Hence, easily means in less time it may reach the body. So time of ascent is less. But when you are coming to downward, it is started with here initial velocity 0. Initial velocity 0. Free fall now. During downward motion, our initial velocity is 0 and it has to overcome the again air resistance. So what happened now here? Which time is more? No, it takes much time to reach the ground. So what I mean to tell you, descent time is TD, ascent time is TA, time of ascent. So which time is more now? Time of descent is more compared to time of ascent. So option C is your answer. Understand? Next, third question. If a body projected vertically up from the ground on reaching the greatest height, this is the ground level. From this ground level, a body is projected vertically up. Assume this is a maximum height. So at the maximum height, our final velocity becomes zero. Velocity zero, acceleration is not zero. Excellent. But acceleration is still acting. That is G. Velocity is zero, acceleration is not zero. Acceleration never becomes zero. Both no. Both are non-zero. Both are zero. No. Only the option A is correct. Here V is zero, but A is Z at the maximum height. Now, children, the body is projected into air from the ground at an angle to the horizontal. On reaching the highest point above the ground, see, this is the ground x-axis. This is the y-axis. Or is it now it is making an angle theta with the horizontal. Now it is projected with initial velocity u. Like this, it is projected. So assume is the maximum height. At this maximum height, what you can observe? Velocity zero, acceleration is not zero. Velocity zero, no? No, it is not zero because here final velocity v is equal to vx I cap plus v by j cap. My vertical velocity may zero, but horizontal velocity not equal to zero, na? Horizontal velocity is not zero here. Okay. But he said velocity zero. Acceleration is not zero. Acceleration is zero. Velocity not zero. No. Both velocity and acceleration are not equal to zero. On reaching the highest point above the ground, both velocity and acceleration are not equal to zero. Option C. Option C. Which of the following statement is true? True or false? Direction of velocity of a body can change when its acceleration is constant. Acceleration is constant. Direction of velocity changing. Ah, yes. Direction of velocity of a body cannot change when its acceleration is constant. It's blunder. Direction of velocity cannot change if the body is subjected to acceleration. So if you take direction of velocity of a body can change when its acceleration is constant. If A is equal to constant, means acceleration is said constant. When we can say the acceleration is constant, if rate of change of velocity is constant. What is that? Change in velocity. Rate in change in velocity. Rate का बारे में क्या है? Rate means divide with time. Divide with time. So change in velocity with respect to time is constant. With respect to time is constant. Means here one velocity, here one velocity, here one velocity. Take this difference. Take this change. And they take this change. If you observe, this change should be constant, but he is not saying that velocity should be constant. Understand? If velocity is constant, acceleration is zero. But here acceleration is constant. Then what happened to the velocity? Yeah, velocity can changes here. Velocity, this value u, this value v. So direction of velocity of a body can change when its acceleration is constant. So obviously, yeah. Which statement is true here now? Option A is the correct answer. Understand, children? Which of the following statement is correct? Acceleration due to gravity in vacuum depends on the mass of the object due to gravity. There is no acceleration due to gravity. Vacuum resistance offered to the motion of free falling body depends on no. Due to gravity in vacuum is same irrespective of size and mass of the object. Acceleration due to gravity will be same. It do not depend. Acceleration due to gravity G is not depend upon the mass of the object. है ना? Irrespective of size and mass G remains the same wherever you are. Why, sir? For example, I am throwing these two objects from certain height. They are falling down. Yes. Whatever the acceleration for this, G only. Whatever the acceleration for this, G only. If I take this and a huge rock also, huge rock, release both. Do the G depending upon the mass of the object now and size of the object? No. So acceleration due to gravity in vacuum is same irrespective of size and mass of the object. D. If a stone is dropped from the window of a moving train is moving now here, and from this window we are releasing dropped means initial velocity 0. It will hit the ground in the following path as observed by the person on the ground observing. What will get? Curved path, definitely curved path. Straight path, parabola, hyperbola, circular. So that is parabola path. Option B. Option B. At highest point of projectile, its velocity and acceleration are. Highest point of projectile. Just now we completed already, but again the question is same. At this point, the velocity and acceleration are. Wow. At highest point of the projectile, its velocity and acceleration are. I have one velocity that is x-axis, but acceleration is, what is the angle between them? They are perpendicular, right. Option B, perpendicular to each other. This is Vx, this is Ay, acceleration. Okay, na? Velocity and acceleration are perpendicular to each other. When a projectile is thrown into air, when a projectile is thrown into air like this, its speed is minimum at where you will get the minimum speed. Here you will get the minimum speed now. Point of projection, point where it reaches the ground, exactly half the maximum height above the ground or highest point above the ground. Highest point above the ground. Highest point above the ground, you will get the minimum speed. Okay, na? Round down. So clear everyone? Because at highest point I have only velocity along x-axis. Vy is 0. My Vy is 0. So highest point above the ground is 0. Option D. A ball is dropped from top of a tower. A ball is dropped from. Yeah. Ball is dropped from top of a tower. And another ball is thrown horizontally at the same time. See here. Ground. Tower. Here you are. One ball is just you're dropping. Ding, 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 released. Another ball is thrown horizontally at the same time. Now one more ball you thrown horizontally. Okay, na? Now what happened? What you observe? This ball is straight away falling down, but it is traveled horizontally certain distance, then falling down. Both are reaching the ground only. Both are reaching the ground only. But based on this, what is asking? First ball reaches the ground earlier, second ball reaches the ground earlier, but both reach the ground simultaneously. What is the height traveled by the first body A? What is the height traveled by the body B? Both are traveling the same heights, displacements. So what you will get from these, and both are traveling under the same acceleration G. So what we can say, both reaches the ground. Yeah. Ball is dropped. Ball is dropped. Yeah. Both reaches the ground simultaneously. Yes. Yes. That is what conclusion. Because both are traveling the same height, same displacement. Both are under same acceleration. So definitely both will reach the ground at same time. Time of descent is same. Why time of descent is same? I'll tell you. Time of descent formula is what? U sin theta upon G. Do it depending on horizontal velocity? No, sir. Do it depending on any velocity along x-axis component? No. Okay, na? So TD time of descent is equal to U by G or U sin theta upon G. If a man wants to hit a target, in what direction should be point his rifle? Higher than the target? Yes, obviously, because just now we have seen projectile motion. If you target like this, then bullet goes like this and comes, hits the target. So higher than the target. Option A, according to the projectile motion. If a body is projected horizontally, if your body is projected horizontally from the top of a tower, time taken by it to reach the ground depends upon, just now we have done. See here, from the top of a tower, a body is projected horizontally, like this it is projected. Time taken by it to reach the ground depends on what? Height of the tower, velocity of projection, both velocity of projection and height of the tower. On these two things it is depending on. Yes, it depends upon height of the tower. Height of the tower. It's not depends upon the velocity of projection. H is equal to gt square by 2. H is equal to gt square by 2. Or from this t is equal to under root of 2h by g. Under root of 2h by g. So this is what the formula. So depends upon the height of the tower, not on the velocity of projection. On reaching the maximum height of a projectile, on reaching the maximum height for a projectile, horizontal component velocity becomes 0. No, blunder. Vertical component is 0. Velocity is 0, acceleration 0. Only option B is correct. On reaching the maximum height, which velocity is 0 now here? Only vertical component. Anyway, Vx is there, but Vy is 0. Vy is 0. Which of the following is largest when the height attained by the projectile is the largest? Height is largest is same. Then which is greater? Range? No, range will be no. Time of flight, angle of projection with vertical, all of this. So time of flight is more because time taken will be increased, right? Option B. Option B. Obviously, time of flight is more. In projectile motion, if air resistance is ignored, means is not considering air resistance. The horizontal motion takes place with constant acceleration, constant velocity, variable acceleration, constant retardation. We know already velocity on x is constant, that is no doubt. Constant velocity. Yeah. Next, children. A bomb is dropped from an aeroplane moving horizontal at constant speed. When air resistance is taken into consideration, what happened to the bomb? Falls to earth exactly below the aeroplane? No. Falls to the earth behind the aeroplane? Falls to the earth ahead of the aeroplane? Flies along with the aeroplane. Like this, yeah. Hmm. So here a ball is, it is going, aeroplane is moving with a constant velocity. Moving with a constant velocity. Okay. From that constant velocity moving plane, a stone is released. So what happens to that? It falls to the earth exactly below the aeroplane? No. Okay. Constant velocity is here, right? But air resistance is considered. Air resistance is considered. So at that time, what will get? Falls the earth behind the airplane. Behind the airplane is won't stop there. It move on. It moves on. But what happens to the stone? Stone becomes back, right? So like this, it falls. Falls to earth Ahead. Sorry. Not ahead. Ahead means front. This is where it is falling now. Behind. Sorry. It is behind, right? Here I given behind. Sorry. Example for horizontal motion with constant velocity and vertical motion with constant acceleration. Horizontal motion, constant velocity, vertical motion, constant acceleration. That is projectile motion. Option D is your answer, no doubt. You need horizontal motion, constant velocity. Vertical motion, you need constant acceleration. So option D is your answer. Wow, this is all about your assignment questions. Now let us enter into the challenges. Quite interesting questions will be there in challenges. So the kinetic energy of a projectile at the highest point of its trajectory is 75% of its kinetic energy at the point of the projection. First of all, let us write the kinetic energy formula. What is that? Half mv square is the kinetic energy. Half mv square is the kinetic energy. But what is giving kinetic energy of a projectile at the highest point is 75% of its kinetic energy at the point of projection. At the point of projection, starting, so I'm taking it as K1. So at highest point, right, I'm taking it as K2. So kinetic energy at highest point, it is K2 is equal to 75% of K1. K2 is 75% of K1. Here, important point you need to remember. Kinetic energy of projectile at highest point. At highest point, what is your velocity? The velocity V is equal to Vx I cap plus Vy j cap. At highest point, anyway, my vertical velocity is 0, but Vx is equal to u cos theta I cap. So find the magnitude for it. You will get u cos theta. So magnitude of this velocity is u cos theta. Okay. Then at point of projection, what is your velocity? At point of projection, that is, this is V2, this is V1. Vx I cap plus Vyj cap. That is u cos theta I cap plus u sin theta j cap. So find the magnitude now. The magnitude of this velocity V1 magnitude is under root of u square cos square theta plus u square. Anyway, you will get u only. Yeah. So finally, what I'm getting now here, you will get V1 is u. Because kinetic energy means we need velocity, right? mv square, mv square. Here you see. Now write down those values, substitute here. Mass anyway remains same because same object. So kinetic energy is of m v square. Final velocity is u cos theta. Whole square, that is velocity at the highest point, is equal to 25 threes are 25 fours are 3 by 4 into kinetic energy at initial position half into mass anyway m and u square v in the place of v, all right. So 1 by 2 1 by 2 cancel. So 1 by 2 1 by 2 cancel. Half mass cancel. Mass is cancel. Then what is the remaining values here? You'll get u square cos square theta is equal to 3 by 4 u square. U square cancel to each other. Then cos theta is equal to under root of 3 by 4. So cos theta is equal to root 3 by 2. Yeah, root 3 by 2. When you will get root 3 by 2? Cos 0. Cos 0 is 1. Cos 30. Yeah. So we will now, so cos theta is equal to root 3 by 2. At what position will get root 3 by 2? If theta is equals to how much when theta, then cos 0 is 1, cos 0 is 1, cos 30, cos 45 is 1 by root 2, cos 60 is 1 by 2, cos 90 0. So cos 30. So cos 30 gives you the answer. So what is your answer now? Theta is equal to 30 degrees. Theta is equal to 30 degrees. Option C follows your answer. Okay. Two bodies are projected at an angle theta. There are two bodies which are projected at an angle theta and 90 minus theta to the horizontal with the same speed. The ratio of their times of flights. So first one, angle of projection. First angle of projection is theta, where second angle of projection is 90 minus theta. Okay, na? So initially the body projected with the theta angle. Next he is projected with the 90 minus theta. With the same initial velocity, he said u. Ratio of their times of flight. First time of flight, what is the time of flight formula? That is 2u sine theta by g. Yes or no? Then, what is second time of flight? That is 2u sine 90 minus theta divided by g. I know that sine 90 minus theta is nothing but cos theta. It's an identity. So 2u cos theta by g. So take the ratio. Ratio of times of flights t1 by t2, which is equal to 2u sine theta divided by g upon, because this is t1, dividing t1 with t2, you'll get 2u cos theta divided by g. So 2u sine theta upon g into g by 2u cos theta. So where the similar values, g cancel, 2u are cancel now. Sin theta by cos theta is remaining, which is called what? Tan theta. So tan theta ratio in tan theta by 1. The ratio will get tan theta is to 1. Option B you will get. Option B. Yes. The third question. Is it clear now? Tan theta is to 1, right? Understand? A person throw a stone with a velocity 10 meter per second at an angle tan theta is equal to 3 by 4. Wow. Listen. A given initial velocity is 10 meters per second, where angle of projection in terms of tan values given. Here, tan theta is equal to 3 by 4 means, which is nothing but opposite side by adjacent side only. Na? If you know the opposite and adjacent, what is the hypotenuse? The hypotenuse of the triangle is under root of opposite square plus adjacent square. Opposite square is 3 square, adjacent square is 4 square. 3 square plus 4 square, that is under root of 9 plus 16, which gives you under root of 25, which gives you 5. Yeah. So what I'm getting now, hypotenuse value is 5. From this, I can go with sin theta value and cos theta value. Sir, why we need sin theta and cos theta? Because it is a projectile motion, right? In the projectile motion, we'll see the horizontal velocity, u cos theta, vertical velocity, u sin theta. That's it. So anyway, so put aside these values. Let us read the question completely. A person thrown a stone with a velocity of 10 meter per second at an angle of tan theta equal to 3 by 4, horizontal from point at distance 8 meters from the wall. From the wall. Okay. So this is the wall. This is the wall. Wall से कितना distance is given? How much distance? The distance 8 meters. Now here is the person. Now he is projecting the body with this angle now. The stone just pass over the wall, just passing the over the wall, just passing, not touching. Height of the wall is equal to how much? What is the height then? Where G is equal to 10 meter per second square. Maximum height attained by the body, u square sine square theta upon 2g. Just now we have seen the formula. But u square is 10 square. Very good. Sine theta. Your tan theta is 3 by 4. Sir, what about sine theta? 3 by 5. Because opposite by hypotenuse. It is 3 by 5 whole square upon 2 into g ka value 10. Thus cancel. 10 into 3 square is 9 divided by 2 into 5 square is 25. 5 2s are 5, 5s are. Okay. Then still 2 get cancelled. 5 ones, 1.8 you are getting. 1.8 meters approximately equal to 2 meters. Yeah, which is 2 meters. Option A. 1.8 nearest value that only na. A ball is thrown means the height of the wall is how much now? 2 meters approximately. It is 2 meters. The ball is thrown by a boy. Is caught 2 seconds later by another at some distance away on the same level. If the angle of projection is 30 degrees, velocity of projection. Simple question. Simple. This is the ground level. This is y-axis. Now you at this position and your friend is at this position. Now you are throwing a ball, but that the same ball is catched by your friend after 2 seconds. Means here onwards, here. The time taken by the body to reach or travel from point of projection to ground. This time is called time of flight. The time of flight is given as 2u sine theta upon g. 2u sine theta by g, which is equal to 2 seconds. We given 2 seconds. And this theta is equal to 30 degrees. Theta is 30 degrees given. But what is the velocity of projection? Apply the same thing here. 2u sine 30 divided by g. G take 9.8. G take 9.8. Okay, now is equal to 2. Then 2u sine 30 ka value is 1 by 2. 1 by 2 is equal to 2 into 9.8. So this 2 get cancelled. 9.82s are 19.6. So initial velocity is 19.6 meter per second. E is your answer. Simple, no? Next question. Cannon ball has the same range or on a horizontal plane for 2 different angle of projection. If h1 and h2 are the maximum height attained in 2 paths for which this is possible. Which one it is possible? We'll get this answer is under root of 4 into under root of h1 h2 you'll get. So we solve this already. So it's an important application. This is possible in this case. This is the D. Ranges are same. Ranges are same. Like this. Here you are projecting the body with the theta. But now here onwards you are projecting the body with 90 minus theta. But both cover the same range. Both cover the range must be same. But height's different. If this is h1 height, now this may becomes h2 height. In this situation, if you calculate the R is equal to 4 into under root of h1 h2. 4 into under root of h1 h2 you will get. It's an application. This already we done in the class. Okay. So fine. So clear. So this is all about your assignment and challenges. So thank you. In the next class, until then, bye. Take care. Have a great day.